Hi, I'm Tom Niedermeyer with the AMF Training School. Welcome to our Partnership Program Maintenance Matters video series. Today we'll be working with the table. AMF strongly suggests that whenever you're working on the Pinspotter, that the power plug should be removed. This is for safety. In addition to removing the plug, it should be put into a lockout box and the box padlocked shut so that no one other than the mechanic who's working on the machine would be able to re-energize the Pinspotter. The table assembly is driven by this combination motor, the motor being attached to this gear case. Gives us a reduction down to 12.1 RPM for the table motor shaft. On the table motor shaft we have several cams, the first controlling this respot lever. This is where the closing and the opening of the respot cells start. Aside of it is the cam and the lever that control the turning of the spotting cups from the horizontal to the vertical in a spotting cycle. Next to it we have a shuttle cam. This controls the movement of the shuttle, permitting pins to be put into the spotting cups. The table movement itself is controlled by a series of cams and levers here, one to control the home position, another the timing of sweep movement, and an interlock protection circuit. Spotting or respotting is taken care of by this solenoid that we find here. When this solenoid is energized, the machine will perform a spotting cycle. When this solenoid is de-energized, the machine performs a respotting cycle. This solenoid then will do everything that needs to happen in order to make the machine spot pins. That is, turning the cups from horizontal to the vertical, removing the shuttle stop so pins are put into the cups, and here, unlocking the table drive assembly. This is what controls the table height, either respotting height or spotting heights. Attached to this table drive assembly is an over-travel clevis supporting the table torque tube weldment. Every preventative maintenance program should include a thorough visual inspection of every component that makes up that major assembly. And this, of course, holds true for the table also. All components would be inspected for damage, excessive wear, or any problem that might result in pins falling rather than being spotted as they should be. The last adjustments that would be made would be putting the individual pins on spot. This can be done with the spotting cup itself. With the table positioned so that the base of the pin is just slightly above the spot, we can see where the pins are going to be placed, and we can adjust this cup to put the pin in the proper place. That is, if we were to loosen the top bolts that we see here, and then in turn tighten the bottom, we would pull the pin back on spot. Reversing that is, loosening the bottom bolts and tightening the top would pull the pins forward on spot. By loosening all of these bolts, we could slide the cup slightly lateral in order to put the pins on spot. With lateral movement, we would need to be careful so that we didn't move the cup so far that it might bind or touch the yoke as the cups are turning from the horizontal to the vertical. We are looking at some of the components here that make up the table assembly in the Pinspotter. This is one of the respot cells, of which there are 10. They can be rebuilt, each part replaced separately. The two fingers, the one to the front and the one to the rear, are identical. These are new style fingers with simply a small pad on the bottom. The wiring from the respot cell goes up into the front of the machine through this cable. This information is necessary in order to indicate when a pin has been picked up by that particular respot cell. Part of our inspection would also include the carburetor type linkage that is used to close and open the respot cells. Here we can make a comparison between the older fingers that had the large insert, made it a little close to the next cell, as compared to the new style finger with just the flat insert, giving us much more clearance. Part of our inspection would include looking at this shifter link. This is part of the table assembly. Its function is actually to close and open the respot cells. As always, our visual inspection would include wear and the condition of bearings. On our table, we find 10 spotting cups. These are used to place the pins on the deck. The newer style cup, as we see here, doesn't use a rubber washer. Earlier style cups did have a spacer inserted here. These cups are webbed together, much heavier bosses here. No rubber washer, but we still have an adjustment screw in order to get the proper spacing between the forward tips of the cups. The cups are held in position by 2 U-bolts. We use these U-bolts then to position the cup in order to put the pin on spot. Part of our maintenance would have us looking at the spotting cup liners. There are 3 of these liners in each cup. They help keep the pins clean, reduce the noise that would occur as the pins drop into the cups. These need to be clean, cannot be sticky, cannot be gummy, or the pins do not slide well. Out in the front of our machine is this table drive assembly. This is what is used to determine whether our table is going to go to spotting height or respotting height. So any work with the table should include a visual inspection for wear in the shafts, roll pins, bearings themselves, to ensure that this will always lock to give us respot height or unlock to give us spotting heights. From this table drive assembly, we have this over travel clevis, which in itself is carrying the table. The actual length of this clevis will determine the heights of the table above the deck. We can make this longer to lower the table or shorter to raise the table. We would, of course, inspect bearings. In the over travel clevis itself is another ball bearing. This one rolls up and back in this clevis when the table rests on an outer range pin. The yoke that is part of the table assembly is attached by 4 legs. There are ball bearings in the top of the legs, spherical bearings in the bottom, and the adjusting screw is used to give this yoke the proper angle so that the pins are spotted on the toe. We would inspect the yoke assembly for any cracks or fractures, the condition of the shafts and bearings. Should the yoke be broken, it can be replaced. However, we do have a yoke repair kit that we can use to make a quick fix. There's actually enough material in a yoke repair kit to make 2 repairs. Also here we're looking at one of the 3 yoke shaft springs. These keep tension on the yoke shafts so that the spotting cups turn smoothly from the horizontal to the vertical and smoothly back to the horizontal position. The torque tube weldment that supports the table on the earlier machines is mounted on pillow block bearings. So we would inspect the condition of the bearings, replacing as need be. These are lubricated for smooth operation. Later machines replace the pillow block bearing with a phenolic bearing, and we use this angle bracket with a pin to support the table torque tube weldment. The table itself is counterbalanced by 2 heavy springs, one on each side. These are on there to make it easier for the motor to bring the table back up from the 180-degree position. One end of the spring is anchored to the table torque tube weldment, the other end to the frame of the machine. Some of the problems that can occur would be the anchor point separating. So we have repair kits to replace the anchor point on the torque tube weldment and also to replace the anchor point on the frame of the machine. These are just some of the parts that we find that make up our table assembly. All of the components would be inspected with any preventative maintenance program. That completes the overview of the table assembly. For more detailed information on its maintenance and operation, you're invited to attend our training program in Richmond, Virginia.